Beginning calculus in 6th grade? Seriously? Yes, seriously. Calculus has been described as what you get when you add the limit idea to analytic geometry and trigonometry, and you get calculus. Now in 6th grade, students don't know, haven't been exposed to analytic geometry or trig, but they've been exposed not to the limit, but to a more basic idea, convergence. They're just not told that it's called convergence. So let's talk about convergence. Once you understand convergence, the limit idea is easy, and you're on your way to understanding calculus. Okay. So in 5th grade, we learn about fractions. 1/2, 2/5, 1/3, etc. That's 5th grade. In 6th grade, or at least this was the grades that I learned this, in 6th grade, I learned about decimals, and I learned about how to convert a fraction to a decimal. So if we have 2/5, we say 5 divided into 2. Doesn't go. We add a 0 here, a decimal point. 5 goes into 24 times, and so we get 2/5 equals the decimal 0.4. No problem. But when we do 1/3, we divide 3 into 1. And we get 3, and that's 9, 1, 3, 9, 1, 3. And so what we say is 1/3 equals 0.333 forever. And for purposes of this discussion, I'm going to multiply both sides by 3. So if we multiply both sides by 3, we get 1 equals 0.999 forever. Now this is what I want to talk about. Saying that 1 equals 0.999, there's nothing wrong with that, but someone could doubt it. Someone could say, wait a minute, on the left, there's the number 1, static. I learned that in 1st grade, 1. On the right, there's a decimal, and it's a repeating decimal. It's an infinitely repeating decimal. And it sounds kind of like apples and oranges. How could the two things be equal? Well, they are, but it's better to describe this as convergence. It's better to describe this as 0.999 is converging to 1. So we say that 0.999 is getting closer and closer to 1. So 0.999 is converging to 1. But that's not the whole story, because 0.999 bar is getting closer to 2 and closer to 100 and closer to 1,000,000. But we do not say that it is converging to those numbers. Well, why is that? Well, because in the first case, 0.999 bar is converging to 1 because it's getting closer and closer to 1. And it's getting as close as we like. as close as we wish. Okay? So 0.999 bar is not converging to 2 because it doesn't get as close to 2 as we could wish. For instance, it's never within 1/2 unit away from 2. It's never within 1/10 unit away from 2. Here, this situation is different. This is getting as close as we like to 1 if we just wait long enough. We think of this here as adding 9s, one after another, after another. And when we've added enough 9s, we're within a millionth of 1, or a billionth of 1, or a trillionth of 1. We just have to add enough 9s. And this ensures that we will add enough 9s because the bar means we keep adding 9s forever. So any tiny number that you can think of, 1 millionth, 1 billionth, 1 trillionth, whatever, this will be close to that if we just add enough 9s. That's not true here. So this is converging to 1 because it's getting closer and closer and closer to 1, and because it's going to get as close as we wish if we just wait long enough. This is the idea of convergence. I mentioned that the idea of limit is easy to understand once you understand convergence. This does not apply to a 6th grader because the limit idea involves a function. But for anyone else who's watching, let's suppose that we have a variable called x, and x equals s. And we say x converges to 1. We write it like this. We say it like this. And by the way, even for students who've been to high school, they haven't seen this idea of x. Here, x is moving. Think of it as it's at 0.9 and then 0.99 and then 0.999. It's getting closer to 1. It's converging to 1. So let's suppose I write this. If x converges to 1, then, and we'll think of any function you like. Let's say 2x plus 5. Then 2x plus 5, now what does that get closer and closer to? Well, it gets closer and closer to 7. Right? Because as x gets closer and closer to 1, this gets closer and closer to 2, and the whole thing here gets closer and closer to 7. Now, if you've seen functions, you could see this. That's a function. And one way to write limit, one way to write the limit would be x converges to 1, so f of x converges to 7. You could also write it if x converges to 1, then f of x converges to 7. These two symbolisms, I think, are very intuitive. Unfortunately, in calculus, a very unintuitive symbolism is used. In calculus, you would see this. Now, I think that's a very unfortunate symbolism because this is the idea of convergence, but then they use an entirely different symbolism to say that the function is convergent. The limit idea is simple. If you are told this, when you see this expression, you are guaranteed that x is converging to 1. And then a typical calculus problem would be, what does f of x converge to? What is the limit? Given that x converges to 1, what is the limit of f of x? And in this case, it's 7. So let's do another example. Suppose you're given this function. Entirely different function now. X plus 4 divided by 7. Okay. Now, if I asked you this, x is converging to 1, what is f of x getting closer and closer to? Well, if x is 1, on the top we have 5, and on the bottom we have 7. That's the answer. And we could write it like this. If x converges to 1, then f of x converges to 5/7, and that means that this is true. So, the idea of convergence, I believe, can easily be taught in 6th grade. So instead of saying, or maybe in addition to saying that this equals 1, you could say that a finer understanding, a deeper understanding, is that it converges to 1. Once you have the idea of convergence, and if you understand the idea of a function, then the limit is easy. You're told that this converges to that. What does the function converge to? We'll do one more example and then we'll stop. Let's suppose we have this function, and maybe I should have labeled this function g or something, not to confuse it with the original. Let's just change that. We'll just make this a g. Okay, it looks a little sloppy, but you get the idea. Okay, so suppose someone changed the question. What's the limit if x converges to 20 of g of x? Well, if x gets closer and closer to 20, g of x gets closer and closer to 20 plus 4 over 7, or 24 over 7. So I believe that some 6th graders, if they weren't put off by the idea of function, could actually find simple limits in 6th grade. But in any event, I believe that convergence is the genuine basic idea of calculus. Once you understand convergence, limit is pretty trivial. Limit says you're given that this converges to that. Now what does the function converge to? What does the function get closer and closer to? And once you have a firm grasp of limit, well, then calculus is yours, assuming that you know analytic geometry and trig and other things. But this is the crucial, fundamental idea of calculus. The limit is often taught and said to be the fundamental idea, but I think I've just demonstrated that convergence is in fact the genuine fundamental idea. Once you understand convergence, limit follows very naturally, and once you understand the limit, you're in the calculus. Thanks for listening.